Hello everyone. So this one is an interesting question. So most of you must be thinking like this is very basic question. So just watch the video till and you will learn a lot new. Okay. First we know we need to draw the output waveform for a step input. 550 is our input. And three conditions are there: R17 greater than R2C2 and equal and lesser. Okay. So what you can see here, like output at t equals to 0 plus, what would be the output at t equals to 0 plus? At t equals to 0, whole circuit would be shorted, so there would be an impulse current flowing through the capacitors, so there would be an instant change in the capacitor voltage, so the output would be C1 upon C1 plus C2 into V, and we can write like 5 C1 upon C1 plus C2. All these concepts I have already explained, that's why I am moving a bit faster. Okay, like whole circuit would be shorted, impulse current will be flowing, so the capacitor would change its voltage immediately. So, and the capacitor and the voltage would be divided in inverse proportion. So it would be 5 into C1 upon C1 plus C2. And at t equals to infinity, we will have R2 upon R2 plus R1 into V. Let's not write V. We can write simply write 5. Okay. So for the first condition, now these are our values: 5 into C1 upon C1 plus C2, right? Another one is 5 R2 upon R2 plus R1. We can write it like this: 5 upon 1 plus C2 by C1 and 5 upon 1 plus R1 by R2. The first condition is R1 C1 is greater than R2 C2. So R1 by R2 is greater than C2 by C1. So this value is greater, so this would be lesser, right? And this would be higher. So this would be higher and this would be lesser. So at t equals to 0 we are having more voltage, and at t equals to infinity we are having lesser voltage, right? So V0 waveform would go something like this. So it would go from this to this. Okay, I'm not writing the values here. So this is for R1 C1 greater than R2 C2, and how will the waveform would look like? How would the waveform look like for R1 C1 lesser than R2 C2? It would look something like this, right? So this would be for R2 C2 is greater than R1 C1. Now for R1 C1 equals to, now third condition is R1 C1 equals to R2 C2. So initial and final values are same. R1 by R2 is equals to C2 by C1. So initial and final values are same. So the waveform would look something like this. So it would be something like this. Okay. So this is V out and this is T. Okay. So the waveform is done. Now the important part is body plot. Now how will you draw the body plots? Okay. So now we will draw the body plots. Body plots. Now first condition is R1 C1 is greater than R2 C2. We have V in 0 plus greater than V in infinity. Okay. Now tell me one thing, at omega equals to 0, like just tell me one thing, like how many poles are there in this circuit? So for finding the pole, you can simply short circuit the input and see if we are having equivalent capacitance and equivalent resistance. So only one pole is there. Okay, one pole is there, and that pole is R1 parallel with R2 into C1 plus C2, right? And how many zeros are there? Zero. So for finding the zero, what you can do, you need to for finding the pole, what you can do, you can simply make V in 0, like V naught by V in, like this is our transfer function V naught by V in, and this is like something like Z2 upon Z2 plus Z1. Now if we make this V in 0, this would be our pole, right? And if we made V output 0, then this would then that would be our pole. Okay, so for making the V output 0, this should be short circuited, and this can be short circuited only at infinite frequency, right? Because at omega equals to infinity, it would provide zero resistance. So this method is failed. So at infinite frequency, we will have a zero. So that is wrong. So now what we can do, we can open circuit this one. Like we can make Z1 equals to infinity, right? If you make Z1 equals to infinity, or V naught by V in would be zero. So that can be one case as well, right? So we can make Z1 equals to infinity, and that would be equal. That would be at 1 by R1 C1, right? Because this is a parallel combination, so it would be R1 plus R1 into 1 upon C1s upon R1 plus 1 upon C1s. So if we make this one 0, this would be infinity. So we have 1 0, and that would be, and this would be 1 by R1 plus, and that would be 1 upon R1 0. Okay. Now for the first condition, this one. Now tell me one thing, like which one is greater? This pole is greater or this 0 is greater? Now you will say we can't really comment because we need the value of R1 and R2 and C1 and C2, then only we can comment. Because this value is lesser than R2, right? This value is lesser than R2 and this value is greater than C1. So we can't really comment by this condition. But we can, so for drawing the body plot, we need the value of R1 and R2. Like we at least need a relation, at one more relation that we need. But that's not correct. We can really draw the body plot as well. So how we will draw? Now tell me one thing, at omega equals to 0, what is the output? What is the gain? AV at omega equals to 0. Omega equals to 0 means infinite impedance. So this would be open circuited and this would be open circuited. So our gain would be R2 upon R2 plus R1 into so this would be our gain, and AV at omega equals to infinity, that would be C1 upon C1 plus C2. So which one is larger? By this condition you can say for this one, this is larger, right? So at infinite frequency we are having more gain, and at 0 frequency we are having lesser gain. So if we draw the body plot, so this is our gain at 0 frequency. Okay, then first pole or 0 would come. So now tell me what would come before. Like at infinite frequency, at omega equals to 0 we are having this gain, okay, and at omega equals to infinity we are having this gain, and omega equals to infinity we are having more gain. So first we have 0 here, and then we have a pole here, because if we had 0 before pole, like this is the DC gain, and then we have a 0, then we have a pole, so it would go minus 20 dB per decade, and then we have a 0. So this would be our body plot. But at omega equals to infinity we have more gain. So for having the more gain, we need to go something like this should increase. So first we will have 0 here. So this would be our 0, and this would be our pole. So this is our gain in dB. So this is our body plot. So that's how we can make the body plot. So this one is for first condition, and for second condition you can draw on your own. So R1 C1 is lesser than R2 C2. So you can draw it on your own, I guess. So it would go something like this. Fine. So by seeing the gain at low and high frequency, we can really comment on the nature of body plot as well. Like first, what will come, pole or 0? So we can comment that. We can comment on that only by seeing the gain at high and low frequency. Okay. Then tell me one more thing. Like for third condition, R1 C1 equals to R2 C2. How would be the body plot? Body plot would be a constant line, because it's a zero order system. Like there is no pole, no 0, and we have a DC gain, constant DC gain. Like at any frequency we have the same gain, because at Zero frequency we are having the same gain, and at infinite frequency as well we are having the same gain. So the body plot would be simply a straight line. So this would be our body plot. Okay, so that's how we can solve this issue. Okay, thank you.